Let's get into a differential leveling example. How does this all work out? On a field note, you're going to find that the way differential leveling is done is on a sheet that looks similar to this. You have column for station, for backside, for height of the instrument, for foresights, and for elevation. And so usually you put the known elevation first. There it goes. Your known elevation in this diagram here is going to be here, arbitrarily shown as 100 feet. What's going on, by the way, here is that this area is how you would be surveying it in the field, and this is what you would be noting. That's what's going on here. When you put parentheses around a number, it means that that number is a known elevation. This also applies to other things too. Like when you look at utility plans or things of that nature, you'll find that sometimes they have parentheses around elevations. That is to show you that this is a known point, a known elevation, known distance, whatever that may be. So what you're trying to do here essentially is go to another point. Go to benchmark number 2. Let's say that you don't know what this elevation is, and this distance between these two is a long way. You cannot take a clear shot to this. So what do you have to do? You have to set up intermediate points. And that's what we were talking about with turning points. So let's say we have a turning point right here. Let's say this is 200 feet from benchmark number 1. This is just an arbitrary example. But let's say it was. So you'd have to have a turning point. On a turning point, the way you would note it is you skip a space and you put it underneath the benchmark number 1. Sometimes people don't do it in this manner. They put it all next to each other, but this is the conventional way of doing it, and I'll explain to you why we skip a space in a moment. One of the things that you have to stick to is that your instrument has to be set up in between benchmark number 1 and your turning point number 1. It has to be as close to the middle as possible. I know sometimes it's not feasible to do, but that is really what your ideal setting should be. In a moment, we will explain why that is. The first thing you got to do is you got to take your backside. You got to figure out where this height of the instrument, where that is in relation to the rod, and which is in relation to the known elevation. So you shoot back at the rod, and let's say you get a number like 3.32. Okay, that's your backside. Backside is an added value. Foresights are subtracted value. That's the way that the field notes are made. So as you can see, that we're going to add all those backside values. I'll tell you what that means in a moment. That 3.32, that's going to go right next to the benchmark number 1. Okay? The next thing, now we know what this height is. We know what the height of benchmark number 1 is. We also know what this backside is. So now, if we add 100 to 3.32, we're going to get this height of the instrument, which is going to be 103.32. And that's going to go in between these two. The way these field notes are made is that you're trying to keep it as equal in order as what you're doing in the field. So this goes in the middle. It shows that this station, this total station or your instrument is in the middle. That's really the idea behind it. So you have your 3.32, you added it to the 100, you get your 103.32. Now you take your foresight measurement. Your foresight comes out to 4.15. That number is now subtracted from 103.32 to get this turning point number 1 elevation. Essentially, we're transposing this line, this elevation, moving it up here, and bringing it back down here. That's really what differential leveling is all about. So that value, 4.15, like I said, is a subtracted value. So we're going to subtract that from 103.32, and we get this 99.17. This is what our value is at this point. This point now becomes a known point. It was unknown before, but now it is a known point. Now, let's say we're going to our benchmark number 2, and again, it's too far. We need an intermediate point. We set up turning point number 2. Turning point number 2, you skip a space just like you did before. You skip a space. You take your backside measurement. It's 2.89. We put that next to turning point 1. Now we have 99.17. We're going to add that to 2.89 to give you your HI. And then you put the HI in between your turning point 1 and your turning point 2. Now we're going to shoot the foresight at the unknown point, which is TP2. That's 4.82. So now we have 102.06 minus 4.82. That's going to equal 97.24. So as you can see, this turning point 1 went from unknown to known point. This turning point 2 was unknown, but now it is a known point. Now we know what it is. So now when we shoot back at this turning point 2, it's going to be a backsight. The next step, let's say now we're within range. Now the instrument is within range of actually giving us a value that we can use. So same type of thing. Backsight, you're going to add that. 97.24 plus 4.15 is 101.75. Then we're going to subtract the 6.45 to move it down here, and we get a benchmark number of 95.30. Sometimes on the exam, what you see is that they don't give it to you in this format. The field notes are in a different format. What they do is they give it to you in what I like to call a smushed up format, which is that the TP1 is right underneath the BM1, the TP2 is right underneath TP1, and so on and so forth, and everything is just combined in a more condensed fashion. So let's quickly go over what that is. TP1 they put right under BM1, okay? And as usual, we have this BM1, so 100 plus 3.32 will give us our HI, which goes right next to BM1. And then the foresight goes on TP1, which is a subtracted value from the HI, and that gives you your elevation. So essentially what's happening here is that since you go into the backside on BM1, that goes next to BM1. The HI goes next to BM1 also because you haven't quite gotten the TP1 yet, and then the foresight is on the TP1 rod. And then if you subtract the foresight from the HI, you get that 99.17. Same with TP2. Backside is pointed towards TP1. HI goes next to the backside, which is again the elevation 99.17 plus 2.89. And that gives you your HI. And then the foresight goes next to TP2 because that is the unknown point. And so we get the elevation at TP2, which is now a known point. So again, for BM2, the backside goes next to TP2. You got the HI next to TP2, and that number is subtracted from the foresight, which goes next to BM2, and then the elevation goes next to the foresight, which is the BM. Now, you might be asking yourself, wow, how am I going to remember all of this? There are two different formats. Well, if you notice in your manual, I have a diagram or figure similar to this, and I show you essentially what gets added to what value. So here you see the 100, this line goes to here, which is the plus. So 100 plus 3.32 equals this minus this number equals this. This number plus this equals this. This number subtracted from this equals this. So just keep following that. Next to this figure, you'll notice that we have the original format as well. And that also has arrows. So you really can't get this wrong. So if they were to take out, let's say, 4.82 right here, if they took it out and they asked you what is this value here, you know that that would be 102.06 minus this number, and there it is. With the arrows, we make it easy for you so that there's no way of messing something like that up. Now, to check your values, the difference between your